Okay, so now, actually I'm going to do this experiment with this copper solution from the pre-1982 penny. So what I need to do is I need to actually pour it and make a dilution of this into this flask. So we never actually add water directly to a solution. So I'm going to pour just some distilled water into the flask, just so the moment that concentrated solution goes in, it's diluted right away. All right, so if there's any exothermic reactions, it tends to be diluted. So there we go. There's a lot of still excess nitric acid in this solution. All right, I'm going to pour some water in here and rinse my beaker many times. Now we could be continuing to rinse this. Because I know that there's a bit of splattering along the top, I'm going to actually take a water bottle and just rinse this all down and make sure that everything is rinsed down. Right. So I have all the copper ions now in here, and I'm going to keep adding water until I get to the line that tells me that I'm at 250 mils. Okay, I'm going to slow down as it gets up into the neck because that fills up very quickly. And then I'm still not there, so I'm going to use a water bottle to go very slowly to add the water. And I don't want to go over that line, otherwise I've added too much water and the volume is not 250. All right, so I'm at 250 now. I'm going to take the cap. And notice the neck of the bottle is definitely more concentrated or more dilute because the water is sort of trapped up there, it's not mixed. So now I'm going to just invert that about 10 times. Now I don't need to keep the solution in this volumetric flask. I've made a nice penny solution. So what's the value of this solution? 1 penny plus the cost of the acid that was used. Any liquids, I always want to just make sure that they're dry. Okay. I'm going to take this and put it into a beaker. So I'm going to take my penny that has been oxidized or reduced. My penny has gone from a copper atom with equal number of protons and electrons to now copper 2+ ions. So they've all lost their electrons. Okay, so there's my penny, and it's all as ions now, and I know the volume of this is exactly 250 mils. So what do I need? I know the volume, I just need the molarity. So I'm going to take a cuvette, and I'm going to transfer a little bit of this copper solution into my cuvette, and we're going to get the absorbance of it. Actually, I should do what I did before. I should rinse it a little bit so that I know that there's no contaminants on the inside. It's good practice. And then I'm going to this, my Kim White. Now, I'm not going to put this absorbance value anywhere on the graph. I'm just going to collect it and put it in my data table. So I put it in here, and right now I'm looking at just the absorbance value of this. The absorbance is 0.483 is the absorbance value, right? So now you're going to take that absorbance value, you're going to look at your standard curve, and you're going to figure out the concentration of the copper ions. You know the concentration now? Molarity times volume is moles. You can then figure out the moles of copper that's in this solution. And if you know moles, you know the moles of copper ion are equal to the moles of copper atoms from the penny. It's a 1-to-1 ratio. And then we can then go moles of copper atoms to mass of copper, and we can figure out the mass of copper in that penny. Now this penny, just a reminder, I forgot to tell you this earlier. When I masked it, this is the pre-1982 penny. It's 3.086 grams. This was not the actual penny that we had dissolved earlier. So this is actually a different example. So this mass, 3.086 grams. All right. All of this data should be organized in tables, recorded observations, and now you have some data to analyze.